Hi guys, and welcome back, grade 12s. Well, actually I should say welcome grade 12s. You should have been watching grade 10 and 11 because I think it's always a good thing to catch up on.
Absolutely, the grade 11 lesson contained a lot of the things that we're going to be doing today. So if you were watching, good on you.
Yeah, and we've got Liesel on today, guys, so this is the time to ask all of those questions. Do you think there'll be lots of them?
I'm hoping that there will be. The show is always more interesting if there's lots of questions.
And we're going over logs and surds. So keep those questions coming. Join us on Facebook. And you know what I'm going to do, Liesel? I'm going to send you straight to the board.
Straight to the board. Well,
Straight
that's
to
what
the
we do
board.
best. Right,
Okay.
guys. So this section that we're having a look at today is exponents and logs and surds. Now, we're not going to go into exponential graphs and things like that yet. We're just going to make absolutely sure that you guys are able to deal with the laws of exponents, the laws of surds, that you understand how logs work, that you're able to simplify certain expressions, and that you're also able to solve for x. This is a very important basis because the other questions, the log graph questions and the exponential graph questions, will be somewhat difficult if you cannot cope with these basic operations. So please, guys, ask your questions. Indy will cue me in. Right, so let's have a look. As I said, we're going to be revising the exponential laws, simplifying surds, we're going to define logarithms, and we're going to use the laws of logs to solve equations. Right, so hopefully this will be very familiar to you. Let's just quickly go over the log laws. Right, so, the exponential laws. The first exponential law is if I have a to the power x times a to the power y, it simplifies to a to the power x plus y. So what does that mean in terms of ordinary things? Well, let's say we've got x squared multiplied by x to the power 3. If I want to simplify that, it will be x to the power 2 plus 3, which is 5. And let's be honest, guys, most of you have known this since probably grade 8. Right, so then just again, what do we do if we've got a division situation? If I've got a to the x divided by a to the power y, I can simplify by saying a to the power x minus y. So that would mean if I had, for example, a to the power 6, and I divided that by a to the power 2, I will quite simply say that 6 minus 2 gives me 4, just like that. Right, let's carry on. The next exponential law deals with multiplication. And specifically, if we have a bracket situation. So let's have a look here. Let's say I have a to the power 2, a bracket around that, everything to the power 3. Then I will multiply the exponents. So now I won't be adding them together, I will be multiplying. So I'll say 2 times 3 is equal to 6. Right. Guys, this is pretty simple stuff, so I'm going to go through it very quickly. If I have a times b inside a bracket, my fourth law, all of that raised to the power x, I am allowed to distribute that power x. So let's say, for instance, I had x squared y to the power 3 all to the power 4. I can multiply that 4 in so that I get x to the power 2 times 4, which is 8, and 3 times 4, which is 12. Similarly, the same thing applies if I'm dealing with a quotient situation. So if there's an x at the top and there's an x at the bottom, you can just make a bracket and say x on the outside. And of course, all of these rules work in reverse as well. So depending on what might work for you, you can do either of them. Then a couple of interesting things that we must absolutely know, and that is that anything to the power 0 is equal to 1. So a to the power 0 is equal to 1, b to the power 0 is equal to 1. 7 million to the power 0 is also equal to 1. Then the next little piece of information that I've circled here In mathematics, usually we try and leave our answers with positive exponents. So if you have a situation where you get an answer of x to the power minus 2, it does look more elegant if you write it as 1 over x squared. And, of course, vice versa. And 1 to the power anything then finally is equal to 1. Right. Now, I think what we need to do is practice the laws of exponents first. We'll do a couple of questions on those, and then we'll move on to the log laws and the other things. So I'm going to scroll to our questions. Get your pens and paper ready. So let's just go past. Right. Okay, have a look at our first question. The first question asks us to simplify. Now, guys, if you were watching the grade 11 show before, this shouldn't be too difficult for you. Right. It asks us to simplify. We have 5 to the power 2n plus 1 multiplied by 3 to the power 2n minus 3, and that is all divided by 15 to the power 2n. Now, the very important thing that Tamlin mentioned in the exponential questions that she did earlier on is she said you have to have a look and see what sort of question you're dealing with. Now, this question, you can see that all of the terms are multiplied with each other. These sorts of questions generally are a little bit easier. We don't have to factorize. What we're going to start off by doing is changing all of our bases to prime numbers. Right, so that's definitely the first thing that we need to do. I have got here 5 to the power 2n plus 1. That is not a problem. 5 is a prime number. I've got 3 to the power 2n minus 3. Again, not a problem over there. The first thing that I need to do is I need to work with my denominator. So I'm quite simply going to rewrite the top terms. The question isn't 100% clear, so if you're struggling to see, there we have it. Right, so now I have to put 15 into its prime factors, and that is, of course, 5 times 3. And I definitely put a bracket around the 5 times 3 so that I remember that this power 2n applies to both the 5 and the 3. Right, now I'm going to simplify. I'm going to get rid of the brackets rather. I'm going to say 5 to the power 2n plus 1. Rewrite it again, 3 to the power 2n minus 3. And as I explained to you guys when we were going through the laws, this 2n is now multiplied into both the 5 and the 3. So my denominator changes to 5 to the power 2n multiplied by 3 to the power 2n. All right, now you might look at this point and say, well, the instruction said to simplify, and it doesn't look a hell of a lot simpler. The simplification bit is coming in right now. At this point in the sum, you have a look at your bases and you say, which bases do I have? Now, I've got a 5 and I've got a 3. So I'm going to combine everything. I'm going to move over to this side. I'm going to say, right, 5 to the power 2n plus 1. And now I'm going to move the 2n that's in the denominator to the top, remembering that its sign changes. So now that 2n becomes minus 2n. Multiplied by, and now I'm going to do the 3's. So it's 3 to the power 2n minus 3. And then once again, the 2n from the denominator comes up to the numerator and the sign changes. So this becomes minus 2n. All right, and this is the point where things start looking a little bit simpler. So what I'm going to do is I'm going to add my like terms together. So I have 5 to the power 1, because the 2n and the minus 2n, of course, cancel out. And then I have 3 to the power negative 3. Now, as I said to you guys earlier, it's considered a little bit inelegant in maths to leave our answers as negative exponents. So I'm going to tidy things up, show that I know exactly what I'm doing. And I'm going to take the 3 to the power 3 to the bottom. Then the exponent, of course, becomes positive, so that helps. And we could leave our answer just like that, or you could calculate the 3 to the power 3, and you'll see that that is 27. Right, guys, so I don't think this is a very difficult question. We should be able to do things like this in our sleep, more or less, by now. Let's have a look quickly at the other type of exponential simplification. Now, that would be a question such as this one. And Tamlin did quite a number of these questions in the previous lesson, so really you should almost be yawning by now. Are they yawning, Indy?
They should be.
Have we got lots of people talking to us today?
We have. I'm actually so impressed. I just want to go over these names. We have a lot of grade 11s from last year that were on the page and now are matrics. We've got Chafikwa, we've got Musa, we've got Cabello, we've got Bahosi, we've got Sylvester, we've got Takalani, we've got Anele. It's all of the grade 11s that are now on the page. And now they're the big dogs in school, right? Hey?
Right. So hopefully these simple little exponent questions won't pose too much of a problem.
Hopefully they're not bored, guys. I hope you're not bored.
Well, we'll get to the new stuff in a minute. So you should in matric be thankful when things are still easy. Right, guys, so this question is different from the previous one in the fact that I've got a sign in between. So just in case this isn't clear, let's just rewrite it. It's 3 to the power n plus 3 to the power n plus 1, and that is divided by 7 times 3 to the power n. Now, in a way, this question is really easy because all of my bases are already prime numbers. So I just need, if they weren't, then you would have had to do that first, so change all of your bases into prime numbers. But that's thankfully been done for us. So now I'm going to carry on with the business of taking out 3 to the power n as a common factor. Guys, remember, in maths, we can't cancel over a plus and a minus. That is just a horrible mathematical sin, equivalent to robbing grannies in the real world. So please, guys, don't cancel over a plus and minus. You have to take out a common factor, and that's what I'm going to do. 3 to the power n. Because I'm taking that entire term out, I'm left with 1. Now be careful here. You're taking out 3 to the power n, but you are still left with 3 to the power 1. What do I mean by that? You might want to skip this step, but if you wanted to, you could have written that second term as 3 to the power n times 3 to the power 1, and then you should see that if you take out the 3 to the power n, you are still left with 3 to the power 1. So we're going to do that. Right. Now, obviously, once you've factorized, it's perfectly okay to cancel. So I can cancel the 3 to the power n at the top with the 3 to the power n at the bottom, and 1 plus 3 is 4, of course, over 7. And there we have our final answer. Right, guys, so remember, primarily in exponents, there's the two types of questions. The one where everything is multiplied by each other. We've done one of those. Look out for the plus and minus signs, remembering that you need to factorize in that case. Okay, Indy, I think we're going to go to a break quite soon and then let everybody take a breather before we get ready for the rest of the show.
Oh, woofsa. Hey, okay, that's exactly what we're going to do, guys. We're going to take a little break. So glad to see so many familiar faces on the page. Bigs up to our sponsors, Macmillan. All of the content that we are going through is from their awesome books, and here's an example of one of those. You guys rock. Thank you for making this show possible. See you now after the break. Hi guys and welcome back, grade 12s. The page is pumping. That's facebook.com/learn extra. Also chat to me, Indy, on Twitter @learn extra. If you have any questions for us, please post them there and we will be able to help you guys out. The page is rocking. It is amazing. I need to do a little bit of I need you guys to help us. We need people to help us, well, your teachers, to help develop content for us. So please can you email or get them to email content@mindset.co.za. I also have to do a very, very special shout out to two very special people, Cabello and Tyson. I met you guys at the Mkamva Night launch on Saturday, and I said to you, you guys said that you'd be watching, and here it is, the shout out is to you, and we'll be dedicating this show to you guys because you guys rock. And I think it is time to carry on with the show. So Liesel, take it away.
Right, I almost forgot. I was so keen to get to the logs that we just quickly perhaps need to talk about our rules for surds. Now, this, again, guys, this should be old news, so I'm just going to go through it quickly. If I've got, let's say, the cube root of 5 multiplied by the cube root of 2, I can say that that is the same as the cube root of 10, right? Then the next thing is if I have a surd covering, oh my goodness, it just took away my square root. Isn't that hilarious? If I have a surd covering a fraction a over b, that power, whether it's a cube root or a square root, can be applied to both. And then also just very quickly, if I have the nth root, let's just do that. If I have the nth root of a, I can write it as a to the power 1 over n. That becomes quite useful. For instance, if you have the cube root of x, it might be more useful in some cases to write it as x to the power 1 over 3. Now, I'm quickly going to do a couple of questions with you guys, just working with surds. They're really not difficult, and they should only take a minute. So let's have a look at them quickly. Scroll past our log. Here we go. Now, the question says to simplify the following, and it would be without a calculator. I have to say that nowadays, you guys all have calculators, you all know how to use them, but imagine you're stuck on a desert island and you really, really need to know what the square root of 75 is. Well, this is what you're going to do. For me, the easiest is to break the number down into its prime factors. So I'm going to list my first couple of prime numbers, 2, 3, 5. Obviously, after that, 7, 9 is not a prime number, remember. Okay, and I'm going to say, does 2 go into 75? No, it doesn't, but 3 does. So I take the next one, and 75 divided by 3 is 25. Now, I know that neither 2 nor 3 go into 25. Now I'm going to say 5 goes into 25 5 times, and 5 goes into 5 once. Then I know if it's a square root, for every 2 numbers that are the same, I can take 1 out. If it's a cube root, for every 3 numbers that are the same, I can take 1 out. If it's an nth root, for any n numbers that are the same, I can take 1 out. So you might want to just quickly do this, show your teacher that you're not cheating. So for every 2 numbers that are the same, I can take 1 out, so I can take out the 5, and I'm left with root 3. So 5 root 3 is the simplest form of that one. Let's have a look at the next one. For the next one, we've got to simplify, again without a calculator, the 6th root of 64. Now, guys, on your calculators, your calculator can put the number into prime factors for you. There's a function on the calculator called shift fact. You guys might want to try that out. Probably most of you know that. But doing it the old-fashioned way, 64 divided by the first prime number, which is 2, I'm left with 32. Next prime, I can still use 2, I'm left with 16. I can still use 2, I'm left with 8, and 4, and 2 goes into 4 2 times, and 2 goes into 2 once. Now, I said to you guys, for every in numbers that are the same, you can take 1 out. So now I've got 6 2's, and I'm looking for the 6th root. So I can quite simply just say that the answer is 2. Another way to do this would be to say, this is 2 to the power 6, everything raised to the power 1 over 6, and then, of course, the 1 over 6 and the 6 cancels, and I'm left with 2. Right. I think there's one more. We might as well do it quickly. They are so quick. So the next expression is 8 minus root 80, everything divided by 12. Guys, again here, we're dealing with that minus sign over there, so please make absolutely sure that you don't cancel over a plus and a minus sign. Let's have a look at what I'm going to do here. I'm going to leave the 8 for now. That looks absolutely horrible. Let me rewrite that. So I'm leaving the 8, and I'm going to look at the prime numbers, prime factors for 80. So I'm going to say 2 goes into there 40 times. 2 goes into 40 20 times. This is hardly hard. 2 goes into 20 10 times. 2 goes into 10 5 times, and 5 into 5 once. So because it's a square root, for every 2 that's the same, I can take 1 out. So I'm going to take out a 2 times another 2. So I'm going to have 8 minus 4. And because the 5 doesn't have friends, it has to stay underneath the square root like so. Right. So that's all divided by 12. Please, guys, no cancelling over a plus and minus. We're going to factorize. So I'm going to take out the highest common factor at the top. I'm taking out a 4. I'm left with 2 minus root 5. And that's all over 12. And then I can simplify. I can say 4 goes into 4 once, 4 goes into 12 3 times. So I get 2 minus root 5. Oops, almost made it 3 root 5 over 3. Okay, guys, that should have been easy. What's the feedback, Indy, on Facebook?
They're all loving the show. Let me have a look here.
I'm hoping they're finding it rather easy as well.
I hope so too. But if they're not, post questions onto the page, just in case.
Absolutely. Right, so let's get on with our logs. Just want to get to the correct page. Oh, no.
Well, Lisa says, enjoying the show, great topic. Just in time because she's writing a test on it this week. We're lifesavers. I love being fantastic. A lifesaver.
That's absolutely
fantastic.
Yeah. Guys, all right, now we're going to make sure that you guys are able to use the log laws to simplify all sorts of things. Remember, guys, the reason why logs were invented is so that we can write the inverse of the exponential function in the form y equals. Right. So let's just quickly first, before we go into the laws, I think it's important that we have a look at log form and exponential form. I like to use a pretty straightforward example. 2 to the power 3 is equal to 8, right? So that's exponential form. We're all very used to it. If I want to write this in log form, it is going to be log to the base 2 of 8 equal to 3. So have a look at the different positions, right? You have to be able to write log form into exponential form and vice versa. And as I said, the reason why logs were invented in the first place, or one of the reasons, if you have a function y is equal to, Indiana, I don't know, I'm out of practice. I am writing like a real crab here.
I was saying to the mindsets, they need to be kind to us today. This is the first day of shows, so we're a little bit rusty, but you know, we're getting there. But while you're doing that, I want to tell you guys, join us on facebook.com/learnextra. I probably don't need to say that because there are so many learners on the page. It's amazing.
That's wonderful to know. Okay, guys, so last year you learned how to sketch y is equal to a to the power x. Now this year, you guys are going to learn about inverses. Now, inverses is all about swapping x and y around. So if I swap x and y around, I get x is equal to a to the power y. But this didn't work for us mathematicians because we want to be able to write it in log form, in the form y equals. So therefore, we invented this log form. So if you take this exponential form and you write it into log form, we're going to get log to the base x of 2 is equal to y, or y equals. So that's why we're doing this. All right. Now, in the meantime, we need to be able to use the log laws. Let's go through them very, very quickly. The first one is the multiplication law. If I have log of x times y, it can be written as log of x plus log of y. So, for instance, if you had something like log 6, you could write 6 as 2 times 3. So then it's log of 2 times 3. And then you can separate it, writing it as log 2 plus log 3. Right? That's the first log law. Second log law is log of x divided by y is the same thing as log of x minus log of y. So let's have a look at an example. So for instance, if I have log of 27 over 2, it might, in some cases, be convenient for me to rather write it as log 27 minus log 2. Okay. And then the final log law is the one that we use the most often, and we particularly use this one when we're doing finance. You'll remember that last year in finance, when you were doing compound interest and things, if you had to solve for n, the time period, we had to use trial and error, or I think they call it trial and improvement nowadays. Now, the third log law makes it possible for us not to have to venture a guess. We can actually solve quite nicely. I'll show you guys what I mean by that in a minute. So if I've got log x to the power m, I am allowed to take that power to the front. So I said that the context here is particularly in the context of finance. So let's have a look at an example where that would be applicable. Remember this formula, A is equal to P, 1 plus I to the power n. This is the compound interest formula. Our end amount, our beginning amount, our interest, and our time period. So let's say I wanted to know how long does it take, how long would it take an initial amount of 1,000 Rand, so that's my P, to grow to 2,000 Rand, so I'm trying to double my money, and of course this will be dependent on the interest rate, right? So the interest rate, let's say that it's 10%. It's a little bit unrealistic, right? To the power n. So now I want to work out that how long. Before, things were a little bit on the tricky side. However, now, things are going to be easier. I'm going to divide through by 1,000 on both sides. So I'm going to get 2 is equal to 1, 1 to the power n. Now, as you guys can see, my unknown is in the exponent. Now, the log laws make things quite cool for us here. What we are allowed to do is introduce a log on each side of the equation. I can do that. I know that about equations. Whatever you do on the one side, you must do on the other side as well. So I'm going to put a log in on both sides, right? Now, the third log law, which is this one over here, which we've just spoken about, says that once I have a log, I am now allowed to take that in and bring it to the front. So this becomes n log 1, 1 is equal to log 2. And I can say n is then log 2 divided by log 1, 1. And that I can simply put in my calculator. Right. So that is one of the places where this third log law is going to be particularly useful. Right. Just a couple of other things that we need to talk about. And one of those that I put it on the notes, and I didn't, is we cannot take the log of a negative number. You guys can check this for me. You can go on your calculator, log bracket -4, and you will see that your calculator cannot do that, and that is because the log function is not defined for negative values. Now, I think you guys should be more or less getting ready to tackle our log questions. We're going to do various different types. We're going to have a look at some simplifications. We're also going to have a look at solving some equations. We're going to practice log form into exponential form. But India, I think we might need a bit of a break before then. What do you say?
I think so too. Okay, matrix, I know that you guys don't really want to break, but we've got to take a break. It's just how things roll. Don't leave those seats. Get yourself a cup of tea, maybe a glass of water, jump up and down, sometimes just to get that blood going, and we'll see you now after the break. Hi guys, and welcome back. We're entering the last 20 minutes of our show. I know that you guys don't want it to end, but sometimes all good things have to come to an end, and there's always next week. Please post your questions on the page, and we will make sure that we get back to them, and we will go over them in the show if we have enough time. That's facebook.com/learnextra. Let me have a look here. Okay, I'm going to do one.
Indy, can I just interrupt you?
Yes,
You must also
yes.
just remind the learners
Yeah.
that these questions are on the website, or will be on the website in due course. So if they want to practice them again, that's what they must do.
So true. Okay, guys, this is sponsored by Macmillan. Thank you so much. You guys rock. That's exactly what I'm going to do. Thank you, Liesel. I'm going to post those questions onto the Facebook page right now and everything we've been working through so you can actually go and work on it in your own time.
Right. Guys, so hopefully you're ready to do some log simplifications. We're starting off relatively easy. These questions are not hard. But at the same time, we're going to be making sure that you know how to apply all of the log laws correctly. Now, the first couple of questions are all similar to this one, where it says, find the value of y in the examples below. Now, the important thing is here that you have to start off by writing the log form into exponential form. That's really, really important. We need to practice that. So remember I said if 2 to the power 3 is equal to 8, which it is, in log form it will be log to the base 2 of 8 is equal to 3. Right. So from the log form, it's actually quite simple. You go, this guy to the power that guy equals that one. All right, so I'm going to start off with the first question. And the first question says, find the value of y in the examples below. So we're going to start off by taking the log form and putting it into exponential form. So I'm going to say 2, that's my base, to the power y is equal to 16. Make sure you practice where everything goes. Now, guys, this is really a very, very easy equation to solve. With our laws of exponents, it really shouldn't be a problem. I can now say that 2 to the power y is equal to, and I want to get my bases the same on either side, and I'm going to say that's 2 to the power 4, and therefore y is equal to 4. So pretty straightforward. From log form into exponential form, bases the same on either side. Very, very important. Right. The next question should therefore be spectacularly easy for all of you. First thing you need to do from exponential form, from log form into exponential form. So I'm going to say 2 to the power y is equal to 2. Now here you really don't need to do too much work. Our bases are the same already. So 2 to the power y is equal to 2 to the power 1. I can cancel the bases on either side. And y is equal to 1. Indy, are people following? They should.
They are indeed.
Let's hope. There's a couple more of these. Right, so now we've introduced everybody's favorite, fractions. I always find it interesting that my students can do things perfectly well until we put fractions into the equation. I don't understand why not. You guys should have dealt with fractions in primary school already, but let's see if we can do this one. Right, so now we get to practice a little bit of our exponential laws as well. I'm going to say 2 to the power y is equal to 1 over 8. So let's do that. 2 to the power y is equal to 1 over 8. Right, now my next order of business is to get my bases the same on each side. So instead of writing 1 over 8, and you can do this in one step, I can write 8 to the power minus 1. Not that that looks like a minus 1. Let's do that again. So remember we said these two things are absolutely equivalent. 1 over 8 is the same as 8 to the power minus 1. So I'm putting in all the steps, but you are more than welcome to skip a couple of them if you want to. Right. So now I need to get my bases the same on either side, and that's not going to be a problem because 8 is 2 to the power 3, so this is going to be 2 to the power y is equal to 2 to the power 3, everything raised to the power negative 1, like that. And then I can cancel my bases, and I can say y is equal to 3 times negative 1, which is minus 3. Right, so that's the same thing. Don't stress about the fractions. Log form into exponential form, and then we go from there. Right, so let's see if there's another one of these. Yes. Now, this really should take you about 2 milliseconds to do, guys. Not hard. 4 to the power y, but I'm hoping that the repetition is getting you guys used to log form to exponential form. We have to be able to use those interchangeably. Right, so again, I need to get my bases the same. I've got two options here. I could make the base on either side 2, or I could just keep it to 4, because it doesn't have to be a prime number if it works for you, because of course 4 to the power 2 is equal to 16. So my answer for this one is y is equal to 2. Right. Ladies and gentlemen, I'm really sorry. I made a mistake here. I can't believe it. 16 to the power y is equal to 4. Guys, that just goes to show you how quickly you can get your log and your exponential form mixed up. Did so anybody true. Pick up? Not yet.
I'm watching to see who picked up.
We are so used to using the bigger number.
Refresh. Let's have a look.
16 is the base. So it's always your base to the y is equal to 4. So guys, I could say that I was just checking to see if you were concentrating, but that would be a lie. Everybody makes a genuine mistake every now and again. All right, so same story. I'm going to say 4 to the power 2y is equal to 4 to the power 1. So then 2y is equal to 1. So then y is 1 over 2. And in fact, I think that one of the previous ones that we had was y is equal to 4 and 16. So I think that's why I got that one wrong. Sure. Okay, let's see what else there is. The next question asks us to express each of the following expressions as a single log and to simplify where possible. Okay, so guys, very, very important. We've got our 3 log laws that we can use. We've got 3 log laws that we can use, and we're going to start now. Now, it's a very useful fact to note that if we have log to the base a of a, in other words, if I can get those two numbers to be the same, then it is equal to 1. So that is something that I'm going to try quite frequently in my questions. I'm going to have a look at my base, and I'm going to see, is there a way that I can get this sort of situation going on where those two are the same, because then I know that the answer is 1. So let's have a look what we're going to do here. I'm going to start out. And guys, remember there's more than one way in which to do these questions. And it's not necessarily a right way or a wrong way. We can all get to the correct answer in a different way. But I'm going to be quite tempted to write the 9 as 3 to the power 2. Right. And then, similarly, for the 27, I'm going to write it as 3 to the power 3. And maybe I should just mention, guys, at this point, if you have a log with no base, if a base is not written there, then the base is 10. All right, so just remember that. I didn't mention that before. Okay, so all I've done really now is write the 9 is 3 squared and the 27 is 3 cubed. What I'm going to do now is take that 2 in the exponent and move it to the front using the third log law. So this is going to be 2 log 3 of 3. And that guy is going to come to the front as well. All right, so now I know that this section that I'm putting into the purple brackets, that is equal to 1, because I've got this situation going on where I've got the same A and A, or in this case 3 and 3. So then this just becomes 2 minus 3, which is equal to negative 1. All right. There is another way in which you could have done this question as well. Let's have a look. Perhaps some of you would have done it like that. We could have also used the second log law. Now, the second log law is the one that deals with the minus. Let me just write it down quickly. It's the one that says, if I have log of A minus log of B, I can write it as log of the first over the second. So perhaps you guys were quite tempted to do that, and that you could have done quite easily as well. So you could have combined the log from the beginning. No problem. Right, let's have a look at another example. The next question asks us to do something similar, but now they've just made things a little bit more interesting by putting in m's and things. So let's look at the instruction again. Express each of the following expressions as single logs and simplify where possible. So we're not necessarily always going to be able to get rid of our logs, but a single log is also considered a decent simplification. Right. So let's have a look here. Now, I've got 7 log m minus 2 log m. Now, guys, this is much the same as having 7x minus 2x in algebra. They are like terms. They are both m's. It's not the same as the last one, though, because that's 2m. So I just need to pay attention to that. So I can immediately simplify my situation quite drastically here by saying 7x minus 2x is 5x. So 7 log m's minus 2 log m's will be 5 log m's. So I've got 5 log m plus 3 log 2m. Now remember, guys, I said to you, all of the log laws can be used in reverse as well. So if you have log a to the power x, you can write it as x log a. In other words, you can take that exponent and put it in front, but you can also do the reverse. You can take something that's in front and put it back into the exponent if that happens to be convenient for you. And it definitely is going to be now. I want to apply the first log law, which says that log of A plus log of B is log of A times B. But I first need to get rid of these guys in front here. So what I'm going to do is I'm going to move that 5 back into the exponent position. So this is going to become log of m to the power 5. Right. And I'm going to do exactly the same thing here. I'm also going to move the 3 back, but now I must remember, perhaps put a bracket that makes it easier. Just remember that that 3 is involved in both the 2 and the m. So a bracket really is a good idea. I think that would probably be where most people would make their mistake in this question. Right. Now, before I apply the first log law, let's just do this. I'm going to say this is log of m to the power 5 plus, now remember it's 2 to the power 3 and m to the power 3. So this is log of 8 to the power m cubed. Right. Indy, how are things looking?
I
People
might
following
even.
so far?
They are. I think I have a question. This one's from Chafikwa, and
Yeah.
she asks, okay, so what if we have log 3, and is it log 4, what, log 3 minus log 4 minus log 3 plus log 5? How will I simplify that? Will I still use the multiplying by the reciprocal rule? Question mark.
What I'm going to do is I'm just going to finish this one off, then we'll write it down and we'll see if we can help her through.
Okay.
Okay, so now what I'm going to do is I'm going to say, instead of saying log of A plus log of B, I'm going to say log of A times B. So let's do that. And that is then m to the power 5. I'm afraid my 5s are looking a bit like 6s, but never mind, times 8 m to the power 3. And then, of course, that can be simplified. Remember, the whole point is to have a single log. So that's log 8 m to the power 8. Power 8, of course, because I'm adding the 5 and the 3 together. So once you know what you're doing, it really isn't that much of an issue. So let's have a look at, what is it, Rafique's question?
Yes, let me have a look.
Okay, what if you have? Okay, let's see. Let's hope it can be simplified.
I hope so. I was hoping that my page will load faster. It's getting there.
Well, so we go on to the next question until...
No, I think I've got it here. I've got it. Okay. So what if we have log 3 minus log 4 minus log 3 plus log 5? And she wants to know how she will simplify that.
All right. Well, the first thing that I would do is I would use the whole like terms scenario. I'd say I've got log 3 and minus log 3. So they would cancel out, like x minus x. So that's already quite useful. And then I would write them this way around. I'd say log 5 minus log 4. And then I would use the division rule and write that as log 5 over 4. You're not going to get the log to cancel out, but at least you've simplified it down to a single log.
Fantastic.
Right, we better keep going because I see our time
is running out.
And you know what else? Our questions seem to have run out.
Well, you know what? You know, I love it. Okay, these are you
just
check
no,
it
we'll
out.
find them.
Okay, well, you look for it. I'm going to tell them, guys. And Tabi Singh says enjoying the show a lot. Mahosi says accuracy. That's exactly what it's about. Mahosi was a grade 11 from last year, who is now a grade 12. So I'm so glad to see the same faces coming back, getting older, kind of carrying on and being mindsetters. And on that note, guys, don't forget that this community is for you. It's for us. It's not just our Facebook page. It is all of you guys. It's a community of mindsetters helping each other to learn more and learn extra. Over the holidays, we've managed to reach 28,299. So we've got one more until we reach that 28,300. And we really are wanting to reach at least 50,000 and maybe the big 1K by the end of this year. So what I need you to do, guys, is I need you to share the page. That's facebook.com/learn extra. Tell everyone you know to like the page and join. And not because we want as many likes as possible, but because we want as many mindsetters coming into one place to help each other out on the page. Okay, so Liesel's nearly done with writing.
That's absolutely fine. I'm just going to write the question on.
Hey, do you want me to carry on talking? You want to carry on?
No, it's 100%. It's first day jitters, clearly. Let's just get ourselves a page going.
I think
here.
so. Okay.
All right. So what I'm going to do now is I'm just going to go through one equation very carefully. And I want you guys to then practice some more of the questions. It's very important that you know the sort of basic steps. All right. So I've got log 5x to the base 2 equal to log 2, and then I've got a little bracket going on here, and I've got x squared minus 36. Now, a very important thing to remember is what I spoke to you guys about earlier on today, and we said that we cannot take the log of a negative number. Right. You guys remember that? I said that we cannot take the log of a negative number, so I have to say that 5x must be greater than 0, right? What does that mean? It means x must be greater than 0 as well. Similarly, over here, x squared minus 36 must be positive, okay? Now, so I haven't started solving the equation yet. I'm just looking at my restriction. So I'm looking at, if I get an answer, am I going to accept the answer or reject the answer, or perhaps accept one and reject the other? So this factorizes into x plus 6, x minus 6, greater than 0. Now on this side, we're going to have to do a bit of a number line so that we can test our critical values. I'm putting the minus 6 there. I'm putting the 6 over here. So I'm picking a value. Remember inequalities from grade 11? I'm going to pick a value between minus 6 and 6. So let's take 0. If I substitute 0 back into my brackets, I get 0 plus 6, which is positive, 0 minus 6, which is negative. So a plus times a minus is a minus. So minus, and it will alternate plus and plus. Right. So I know a couple of things here. I know x must be bigger than 0. That's my one restriction. I'm going to put this one in here. So let's put the 0 there. So this restriction says x has to be bigger than 0 and minus 6. Now, guys, I will then be working only with values bigger than 6 because that is where all of my conditions are met. Right, so just remember at the start of a log equation such as this one, they're not very common in the papers at the moment, but it is a useful tool to have. Remember that we cannot take the log of a negative number. Then once you've dealt with that, it's actually quite straightforward. Because I've got a log to the base 2 on either side, I can just cancel them. And I then get a trinomial, x squared minus 5x minus 36. All I've done is I've taken the 5x over to the other side. I'm going to factorize this trinomial. That's going to give me x minus 9, x plus 4. And if I then look at my two solutions, my solutions are either x is 9 or x is negative 4. Now, remember I said it has to be in this region, so what I can do is I can reject my answer of x equal to negative 4. But guys, that kind of makes sense, because if you put minus 4 in the place of x there, you will be taking the log of a negative number. So I've got one more equation that will be on the website, but just before we finish off, for those of you that maybe want to give this one a try, copy it down. It's log to the base 7, 3x. Indy, I don't know what's happening with my pen today.
Well, I think we've got 1 minute and 20 seconds.
I'm just writing the question down. So.
Quickly.
This one is ever so slightly less complicated because we're not dealing.
Okay, Liesel, I'm going to have to take it away from you. So mindset is what I'm going to tell you is that I have posted the show notes onto the Facebook page. Please go and download them, have a look at them,
then, yes.
and they'll be in the notes, right? Okay, we're not coming back because this is the end. Matrix, you have really come out and you have shown full colors. Guys, put questions onto the page. We will get back to them. You can also email helpdesk@learnextra.co.za. And also, if you've been watching, you'll be seeing that we are doing a presenter search. We've done auditions 1 and 2. And you need to watch out on the page because you need to start voting next week. But we'll tell you more about it this week. check out the Facebook page, facebook.com/learn extra. And I hope that you all had the most amazing time. Matrix, we cannot wait to spend 2013 with you. We know that it's going to be amazing. We are here straight from the beginning to the end. Thank you so much for joining in. This has been an awesome, awesome first show. Thank you so much to the technical crew. James, the director, you are the best. Macmillan, you rock. Thank you so much for making this show possible. You guys are awesome. Thank you, Matrix. See you same time, same place next week. Bye.